we'll see how PTC Mathcad will help you to address those challenges. How it made, with PTC Mathcad, you can make engineering calculation easier and simple. Then quickly, I'll walk you through a demonstration uh, with a problem statement and a template, and explain you how things can be done easier by using our Mathcad. And then I have a customer success story to share it with you. We'll share a customer success, like in terms of an engineering calculation. As an organization, they were able to reduce almost, for them to do engineering calculation initially it took almost weeks together and months together to do that, and we'll see how easily they were able to reduce that and bring that drastic change in terms of time and achieve that speed to market, time to market at a faster rate by using our Mathcad. Then at the end I'll also have Q&A session. So during this session, if you have any questions, please make note of that question. I'll be happy to take that question and address that at the end of the session. So with that said, I'll start the session today with the introduction, who we are. So for them who are an existing customer and who are very much familiar with PTC, that's great. And for them who are completely new to PTC, so these are our basic elements of who we are and what we do. So PTC is a $1 billion global software company headquartered in Boston, and we help other companies to reinvent the way they design, manufacture, operate, and service things in and for a smart connected world. So we have our solutions catered with industry on CAD, PLM, IoT, and AR. So with respect to CAD, we have our a flagship product called Creo. Earlier it was known as Pro-E for all the 3D design, product design. And in order to manage their entire product development, for that product lifecycle management, we do have Windchill, which has been industry leaders in terms of product lifecycle management solution. And also with the current buzzword in the industry with Industry 4.0, Internet of Things, like industrial IoT, we do have a solution that is called ThingWorks, which can help you to cater into that Industry 4.0, as well as with respect to AR, augmented reality. We do also have solution that is called Vuforia. So today I'll be talking about Mathcad on engineering calculation that comes under CAD. So if you wanted to also have more information, or if you wanted to request to have a webcast on PLM, IoT, or AR, what all the solution that has been offered by PTC, you can feel free to reach out to me or ACA team. We will be happy to help you to do a session on that. So with that said, we have around 28,000 active customers globally, and we are around 6,000 employees, again globally, with almost 1/3 of the employees are into R&D, and you can see that there are a lot of efforts gets into R&D, so that if there is any disruptive technology which is coming in the market, we are coming up with a solution to also help companies to transform and achieve that technology forward. So that said, we'll start with the challenges faced by organizations when they are into any sort of calculation, engineering calculation. First of all, for any product development, it might be with a different segment. You might be from a mechanical team, or you might be from a civil, or you might be from an electrical team. So when you define a problem, when you wanted to do any some product or do, first of all, you start for everything. The basement here is that mathematics, right? You go ahead and define the problem statement. This is how you need to end up. So to doing that, for doing that, you have lack of standardized process and tools to capture calculation and intellectual property. So when you go ahead and define that this is my product, and you say that this is all my requirement, how do you achieve that? You also wants to go through that mathematical calculation, referring a machine design handbook, or you do that on a traditional way of doing it on a paper, or doing it on a spreadsheet or a Excel sheet, and documenting that. And doing that is you're not following, companies out there are not following a standard process of how things can be brought in more easier way, so that at any point of time you can reuse that. You need not to go ahead and recalculate, because when you are into a product design, there will be a lot of design iterations which you will be doing it, right? So every time you cannot go ahead and change the value and recalculate the entire stuff, and it would take a lot of time in order to narrow down to an answer with different design iteratives. So you should be able to have a solution where within no time, if you go ahead and edit a particular value dynamically, it should update the results, as well as you need to standardize and create a template so that you can reuse that whenever required in future. Or else if a person you joinee or a person who is not responsible for this product, if he joins your team, and it should be a document should be a self-explanatory, so that if he just goes through that document, he needs to be able to understand how things you have done and how you have derived this equation, and you found that solution for the problem what you are doing it. So that is not been, that's a pretty challenge today in the industry out. They are using a lot of different solutions. It might be spreadsheet or VB Visual Basics. Engineers are forced to learn programming language as well as complicated environment in order to bring up that in a more reusable format. As well as when you do that, sharing and reusing of calculation and protecting your intellectual property is a bigger challenge today. And I say protecting your intellectual property, for an entire problem statement, you would have derived a formula there, and that would be the key for your problem, and you need to protect that, right? A person who is not involved in this, or by chance, a person who's just wanted to view and interact with that, might end up doing some error with that particular formula there, and again everything goes on a toss. It's a human tendency, right? You might end up some doing errors. So in order to protect that intellectual property, you should have a solution there. And also, errors are very hard to catch when you're working on any programming or defining the problem statement with backend. And if there is something wrong, or if you do a simple mistake, to identify that mistake and where that has gone wrong, it's a bigger problem today, and it would take a lot of time to catch, get that problem and sort it out. So that's a bigger challenge today in the market. So to address this all challenges, PTC, we come up with a product solution called Mathcad for any engineering calculation, which will help you to analyze your problems, solve it, document that, and also share along with your peer employees, your colleagues inside an organization, so that it makes easier job for you to help them to understand the problem. It's a self-explanatory document. No need to go ahead and say, explain them how things are done if you are doing it on a programming or any other spreadsheet or an Excel document. So first of all, I'll talk about the capabilities. It's a digital engineering notebook to perform your engineering calculation and manage your design intent. So as an engineer, you are not forced to do this kind of programming language for any for any problem, engineering problem. You're not being forced to learn this and work on that programming language in order to narrow down to your solution. So what PTC offers, it's a completely a whiteboard intuitive user interface. So you can go ahead and define the problem statement as you do it on in your in your notebook or in a piece of a paper. You write your formulas down, define the constraints, then you solve that problem. And as you do any changes or an update, you can see that dynamically the problem will update, and you're not doing, this is not what you need to do. This is what PTC helps you to increase the efficiency as well as speed up the time to market by using a right solution early in the product development process. So it combines the ease and familiarity of engineering notebook with powerful mathematical engine at the back end. And as I said, it's intuitive as well as easy to use whiteboard with natural math notation. You can see that how you go ahead and define in terms of, you define the what is X value, what is the formulae, everything as you do it on a piece of paper or a notebook. So you're not doing any coding here or programming, or you're not using any spreadsheet, words there to bring up the relationship between the two variables or things. So it's a comprehensive combines live math, text, graphics, and programs in a single readable form, and manages units automatically. This is a added advantage. As an engineer, sometimes you might end up using a different unit system, and that will the entire problem, because of that small error there, would will result in a big mistake. So if at all, like if a software helps you to guide you, also if it gives you a feedback whenever you're putting a wrong unit system into a mathematical calculation, that will boost the engineer confidence level, as well as it will help them to work flexible, and they can work confidently on a problem statement, saying that if I do any sort of mistake on unit system, I have Mathcad which will highlight me, saying that this is not the unit system or a variable which you are trying to bring into a formula there, and this is wrong. So that gives an added advantage when you go ahead and use our Mathcad. As well as it is self-documenting. As you see that, you go ahead and define the problem statement and when you export that. So whenever you wanted to share it across to your colleague, you can go ahead and do that within no time. So it's what you say is what you get editing document, as well as you have rich numerical function library. I'll walk you through with that on a live demonstration. You can see that how easily I would be able to, enter any problem statement and write a simple formula for that problem. And I go ahead and calculate that. And if I do any changes, how that result will dynamically update. And also for any calculation, definitely you would need to, go ahead and plot xy, polar plots or a contour 2D plot or a, graphs. So those things are made simpler inside our environment. So I'll also walk you through during a demo that how easily you can go ahead and create or customize a graph or a 3D plot according to your need. As if you have any standard templates for your organization, you can also bring in that templates for the visualization purpose. And lastly, as an organization, if you are into any 3D design of your product, sorry for that. So as an organization, if you're using any 3D CAD software, creating your CAD model or working on any product design, you can go ahead and integrate our Mathcad with that environment. So what I mean here is that you can always do a calculation driven design. So that will help you to ease in the work. You document that design intent. For an example, you go ahead and work on a particular product design for this piston head. So you define the parameters, like what is the diameter, what is the length, and you can bring that information back into our Mathcad environment. You have that link between a calculation tool as well as the 3D modeling tool. So once you bring that, you go ahead and do different iterations here, find to in order to achieve the goal. Might be the efficiency what you're looking for. It might be the output. So when you say efficiency, you go ahead and vary. You go ahead and work on multiple iterations, varying the diameter or the length, so that end of the day the idea is that you need to achieve that efficiency, right? So you might find out this is the right diameter and this is the length of the piston which should be in order to achieve the efficiency what you're looking. So you once you got to know that this is what the value should be, you can bring that value back into the 3D environment, and at a click of a button you can go ahead and edit that. You need not to start from scratch, as you already brought in the values into our Mathcad environment. Then you are taking back to our 3D environment. At a click of a button, the entire model what you have been is able to regenerate. So that's why we call it as analysis driven design or calculation driven design. So this is also an added advantage for any mechanical engineers out there. They wanted to do any calculation driven designs. You can also verify and validate the results what you have got it. So with that said, those are all the few functionalities I wanted to highlight before we go ahead and start the demo there. So what I'll do is that I'll quickly go ahead and switch between the tabs. Like I'll go get into my Mathcad environment. So Vinny, can you just confirm whether you're seeing our Mathcad screen?
Yes, Omar. Sorry, yes, we not.
Yep, no
Sorry.
problem. Thanks for that. Just before I start this live demo here, I would like to give you, insights what I'll be talking about. Uh, First of all, I'll do two demonstration so that you have more understanding what is Mathcad. So the first demo here is that it's a basic demo. I would like you to walk you through how easily you can use or create a document by using our Mathcad. What are all the functionalities you can do by using Mathcad on an engineering calculation? And the second demo is that I have defined a problem statement. I have worked on a problem statement. I'll walk you through what is a problem statement, how I was able to, bring in all the related information or formulas into that environment, and how I'm able to calculate that, the goal, what I'm trying to achieve it. Okay, so that's an insight. So quickly, what I'll do is that I'll, uh, start the demo here. So PTC Mathcad has all your engineering, notebook ease of use and familiarity with live mathematical notations and unit intelligence. So let me go ahead and define my problem statement here. That is deflection in beam. So most importantly, the calculation capabilities produce far more accurate results than a spreadsheet can provide inside Mathcad. And you can present your calculation with plots, graphs, text, and in an image in a single professional formatted document. And nobody needs a specialized skill to understand PTC Mathcad data. So I've defined the problem statement here. And also within Mathcad, it enables engineers to insert embedded objects from an external applications, like it might be your Excel document, or it might be your PowerPoint information, or it might be your PDF, or any other formats which you wanted to bring into our environment. For an example, if you see at the left side, I have this image which I have brought in from a PowerPoint. So quickly I can go ahead, double click on that, and go ahead and edit that information. So for an example, if I go ahead and do a simple edit, like change the color of this axis here, just for the representation purpose for this demo, a simple operation. So let me change this color so that it's an axis there. And this would be updated right back in my Mathcad environment. So also, as you know, Mathcad uses natural math notations and live calculation. This natural math notation allows engineers to simultaneously solve, document their calculation the way they learned in school. So you can see that I'm defining the value what is B and D for that, and I'm putting forward the calculation formula for that. So this is how easy you can do that. So engineers are not forced here to learn a programming language or a proprietary scripting language. So calculation can be easily understood, verified, validated, and reused. So I can also, go ahead and edit this equation, quickly change the expression of that equation, and you can see that if you make changes, the content, the expression will automatically update. So that is how it's fast and dynamic it is. And I can also, bring in the unit systems there. The hallmark for Mathcad is that the how the units are managed inside our environment. So units can be changed easily, and when an operation, for an example, if you attempt to bring in an incompatible variable or incompatible units into our environment, Mathcad will not allow to do that. You can see that these units are not compatible. So you can see that this gives more flexibility, as well as a dynamic support for any engineers, which will help them to save time and avoid mistakes in future. There, you need not to go ahead and recorrect the entire problem statement what you have done. So as well as PTC Mathcad can also read and write a data file such as Excel. So you can see that I'm trying to import an Excel document inside a Mathcad environment. So we are using read Excel function inside Mathcad to insert an Excel document into a Mathcad environment. So once you do that, if you wanted to not bring in all the information inside the document, you can pick and choose like how many rows and columns information what you wanted to bring in, and you can use that function inside the Mathcad environment. So Mathcad contains over 700 built-in functions such as read Excel function, and if you wanted to quickly change the different values to be brought inside from an Excel document, you need not to go and import that back from an Excel document. What you can do is you can quickly change the rows and columns there, and it will update automatically. So let me go ahead and put forward the equation for Young's modulus of selected material. What's the formula there? And you can see the results getting updated. And also as a user, you can also bring in different defined functions like y of x function to calculate the deflection of beam. So I can go ahead and say what is the length of the beam, what is the load acting on it, and what is the distance from a load position from point A, as well as other force balance diagram. This is all I have defined just for the demo purpose, so that we can quickly walk you through the complete capability and how strong is Mathcad in this place. So you can define all the boundary conditions, what is left end, what is the right end, and force balance equations you can bring in. And more importantly, as I said, you can protect the intellectual property. So this is the deflection formula which I'm using to calculate. And if I feel that, I wanted to protect and secure this formula, like in future, if a person who is referring this document or a person who is completely new to this product, if any by chance, if might go ahead and do any mistakes, or if we can go ahead and, edit this formula, then the entire problem statement or problem definition will go on it. So I don't want to take a risk over there. So I need to protect my intellectual property there, so I can have that password protected area. So a person with right password can able to go ahead and edit that, environment formula. So to just calculate the deflection of a beam here, I'm bringing in the equation, and you can see that it's in meter now. As in, I wanted to change that into a millimeter. Just you change the unit system, the result will get updated within no time. So in this expanded area, so we can also see some symbolic calculation. This means that we can calculate expressions with variables and symbols and obtain the results in a symbolic form. So unlike numerical, evaluation with symbolic algebraic math, we can calculate expression without assigning values to variables. So symbolic results can reveal relationship among variables that might not be apparent from numerical results, and the calculations are easier to review and understand. So here the deflection again, it's in meter. As I wanted to change that to millimeter, just click of a button, I change that unit system, it changes that into a millimeter. So also it's incredibly useful to display resulting data using an Excel object. We have done that here. Notice that I have double clicked on that Excel object and I'm doing a slight changes to a simple an update of changing the color and changing the font and making it how I wanted to look in a document. So you can go back and see that that would have been updated inside our Mathcad environment. So lastly, you can also edit the plots. So as per your company standards, so you can double click on that and you can work on the templates, how you wanted to look. For example, work on the chart legends and title of that. You can go ahead and rename what is that particular plot you're plotting. So deflection of curve is my plot here, and use the basic functions there. How you wanted to define the x of x, what is x, distance along beam, what is y again, deflection, and you can represent that with a different coloring there. So we are making it, interface which is more user friendly, so that end of the day, an engineer working, if he wants to customize the template according to his company standard, he can go ahead and do that. It's not that we have some certain standards color coding that only you have to use. It's up to you as per your, if you wanted to reuse this in any PowerPoint for a presentation, you can pick and choose your company template color coding, and you can go ahead and do that. That's made easier inside Mathcad environment. So this is with respect to 2D simple graph, what I would try to plot it with all the deflections. So you can also go ahead and plot contour plots as well as a 3D plot. So for an example here, let me go ahead and use a 3D plot to visualize the function of two variables, a vector valued function or a 3D data set. So we can plot surfaces whose nodes are connected into a mesh, curves in 3D space and skated data points. You can spin, pan, zoom, you know, to visualize and interact with that 3D plot to understand more. So with that said, this is a simple demo, just a basic demo. I just wanted to walk you through how simple it is to define a problem statement inside our Mathcad and go ahead and bring in all the formulas what you wanted to bring and how you wanted to calculate. Inside you saw that how easily you were able to dynamically edit and change the unit systems, and the results are getting updated within no time. So the next demo which I would like to walk you through here is that on the a specific template which I've created. Let me reshare the screen. Just give me a minute, I'll reshare my screen here. Yeah, so I hope you can see the screen now on the engine. So that the goal here is that uh, as an engineer, I wanted to maximize the ratio between volume and surface area to increase the overall efficiency of the engine. So for that, this is a problem statement. So for that, what are all the information, how I would do? I've created a template and I'll be walking you through with that. So you can see that we have a diagram which I've brought in, which will help you to understand the bottom dead center and the top dead center of that. And also the maximizing the ratio, the formula which is more important for this. So how I wanted to do that, I'm going to go ahead and highlight that. That's my goal. And the statement I have defined next to it, it's maximizing this relationship will minimize the heat and pressure loss during the combustion, which improves the efficiency of the engine. So that's the whole idea of my problem. So once you have that, you wanted to define the constants, right? For any problem, you have some constants, right? You need to go ahead and define that constant. You can go ahead and do that and say that this is the constant for entire problem. For this entire problem, this is, if you go ahead and mention D minimum, displacement minimum, that will take that value. So this is constant. So the minimum and maximum displacement of engine, what is the compression ratio of that engine? So this is termed as constant, which I wanted to use it for this entire calculation. And also there are different variables. You wanted to define the variables, right? What is piston bore diameter? What is piston edge thickness? You define that along with the unit systems. So what is the unit you are using for this formula again? So you go ahead and define the variables for that particular problem, and also functions for a spherical cap volume and surface area. So this is all the data which I would have referred from a machine handbook or from a different designs. So I can bring that data back into Mathcad environment, how you do it, on a notebook or on a paper sheet of paper. You see that I've defined the volume of spherical cap, surface area of a spherical cap. So if you closely observe, I'm not using any programming language or any, hard different language. It's completely ease of use and intuitive user interface. I'm trying to just use the basic functionalities. I'm trying to type and bring in the values there. So I also have some constraints for this problem. So what is the constraints I've defined? The compression ratio should be within 7 to 9. And the engine displacement should be between 3.25 to 3.33. These are all my constraints which I have to adhere to it, and I have to achieve the goal what I was looking for. So finally, I come up with the formulas for that. So how do you derive that? What are all the basic formulas you had derive? Along with that, you can go ahead and define. As I said in the previous demo also, it's not that just you go ahead and define the values. You can go ahead and define the formulas and derive an equation out of it, and so that in future, if a person is referring to this document, he can understand how did you end up calculating this, what are all the formulas you have used, what is the backing, like how do you pursue with this. So all that it's a self-explanatory document. You can see that barely any person who's going through this can understand how you have derived this equation. What is volume to surface area relationship? What are all the formulas you have used to derive that? So that is what I was talking about. It's how easily you can do. So you can see that height of piston head to height of engine block. Uh, in order to have that volume to surface area relationship, I have derived it from the formula. And I can also plot characteristics curves for volume and surface area. So what I can do is that I can use that formulas which I've used here for volume of each cylinder, volume of piston head, volume of engine block. I can give a value to that and I can plot and see a graph for this particular formulas I have used. So I've done that. Like, let me go ahead and expand that area here, plot the characteristics curves for volume and surface area. So let me go ahead and expand it. Yeah. So for that particular, formula, I've also given what is the height of the piston, and I've defined the value there. With respect to that, you can see that it's plotting a graph over there with this respective values there. So end of the day, you're using the same formulas and using plotting the graphs along with it. And you can see that for performing any optimization, what is the formulas I've been using. So this is my goal, right? Perform that optimization. You can see that I can go ahead and if you want to have that password protected area for this particular optimization study, you can do that. You can go ahead and protect that area. So this is more important in this particular problem statement. If this has been edited or if there is any changes to this, the entire thing goes on a toss. So you can go ahead and protect that. What is that? And you can see the formulas I've used for calculating this. Height of piston head to height of engine block, the maximum, volume to surface area, that in order to maximize that, so that end of the day I'll be able to get that, I'll be able to increase that efficiency. So the optimal height of piston head spherical cap is what, this much, and the optimal height of engine block for a spherical cap should be 43.754 mm. So that's the value we have been ended up doing it for this problem statement. And I can also have that requirement verification done there. And also you can use this data to be used into and you can put this in an Excel document. It's You can change that. Yeah. So here you go. You see that design summary. What is the values? What you got it from the calculation? You can use that in an Excel document. So I double click and go ahead and see that. I can go ahead and edit in an Excel document and come back to our environment. So as simple as that. As well as if you feel that a person in future, if someone is referring this document, they wanted to understand how I have narrowed, like what all the formulas, where did I refer this formulas, how to derive this equation and solve this problem. What you can do is that you can quickly add some reference documents or links which you wanted to put into this document. So I can go ahead and click on text block. I can say that a reference book which I've used for bringing up using this equation inside our environment. So reference might be I've used, I browsed some inside the browser. I would have used calculation formulas from this website. So I'm going ahead and putting that as a reference here so that in future someone is referring this document, they can understand this is where the formulas I brought in, I referred, and I'm reusing that for this particular problem. So I can go ahead and link that address. So anyone who's clicking on this document can divert that to a browser environment. So that's what, with that said, you can see that how easily I was able to define a beginning of a problem statement, also an existing problem. So as a layman, like as a newcomer to our environment, you can see that how easily I can understand what what is this problem, improvising engine efficiency through optimizing the piston head profile. So what all things I have done, what my colleague who was prior to me worked on this, spread in this Mathcad document I've done. So you can easily understand, you have clearly defined what are all the variables, constraints, constants, and then the formulas used as well as the graphs you have plotted. And this makes easier for any engineers as well as saves time instead of going ahead and learning a different programming language to do any analysis or carrying out bringing any equations or calculating that. So that said, I'll move back to the slides. And end of the day, by using our Mathcad, you would be able to prevent loss of IP and improve the knowledge capture. So you can see that by using a password protected, you can go ahead and protect the areas which you feel that it's very important. If that has been edited or tampered, that entire thing will go on a toss. You can go ahead and have that password protected, and you can optimize critical design and engineering process. For an example, if you are using a calculation driven or design or an analysis driven design, you can have that link. As you saw that the final, what was the length and what was the diameter I got, I can reuse that value back into my CAD environment, and at the click of a button that my design would be able to update within no time. So once that is updated, as a design engineer, your job is made easier. You need not to go ahead and double click on that particular parameter and edit every time you do any different iterations or things like that. And lastly, you improve your product quality. That is more important, right? End of the day, any engineer who is working on any product design, he wants a better quality of product that, when it goes to a market, it has to withstand and also perform good with respect to its competitive products in the market. and speed up time to market. This is more important with traditional way of doing it. Like when you're using a different spreadsheet or a document, it would take, if you do any editing or if you wanted to reuse that document or if you wanted to identify a problem or any error what you have done, it would take a lot of time. But doing it in a simple document, easy to read, easy to use, intuitive user interface, it will help you to speed up time to market. End of the day, it's a win-win situation. So it also improves compliance with regulations. So if you feel that if you wanted to have that yes or no kind of answers, like if it passes this test or not, all those things can also be done inside our environment. So as I said during the introduction, I also wanted to share you a customer success story. So this is what I was talking about. ZF Wind Power completes calculation 90% faster with PTC Mathcad. So this is what the statement are, a customer were able to make with by using our PTC Mathcad. Prior to which they were able to not do or achieve that. Like first of all, we'll see what ZF wind turbine is. Then I'll also walk you through what was their problem or initiative and how did they address that by using our Mathcad. So ZF Wind Power is a globally established designer, manufacturers, and suppliers of reliable, custom-built gearbox for multi-megawatt wind turbines with a power capacity ranging from 1.5 to 6.15 megawatt. So one of their engineer, what he has to say with Mathcad is that, with PTC Mathcad, I'm able to solve calculation problem in 1 day compared to 1 or 2 weeks it takes programmers using Microsoft Excel or Visual Basics. You can see the impact here. A senior technology engineers felt by using our PTC Mathcad on a day-to-day daily life. So I have been doing things with PTC Mathcad that people said could not have been done. And the initiative what ZF Wind Turbine initially had was that they need to reduce repetitious work and leaving team focused on engineering problems. So when they say repetitive work, they don't want to, when they are working on multiple iteration, you don't want to, go ahead and again do the changes, or if you wanted to identify where the problem gone wrong, all those things, it would have taken a lot of time there for them. So they wanted to replace that with straightforward, easy, understandable, easily defining a problem statement and doing a problem. So that was what they wanted to do, that so that their engineering team is more focused on engineering problem rather than finding out a mistake or doing a repetitive work there. And also they wanted to improve accuracy and repeatability of complicated calculation, so and minimize tedious programming tasks. Earlier they were using different tools to do that, and they wanted to minimize that programming requirement there, and create and modify complex model geometry efficiently, as well as automate data and workflow management. So this was the initiatives which they had, and what PTC helped them. What was the solution we offered them is that PTC offered a solution for engineering calculation, that is our PTC Mathcad, and followed by 3D design, that is our PTC Creo for them, as well as data management tool, that is Windshield. So it's a suite of solution we offered them so that they overcome and address the challenges what they were facing during the product design. And with PTC Mathcad in specific, the calculations are developed once saved in worksheets and are also reused. You can see that I had showed you right the template which I have saved for a particular problem on engine efficiency. Likewise, you can create different worksheets, save that. Whenever you wanted to reuse or you wanted to do a different iteration, go ahead and change the values, and you can see that the results will get automatically updated within no time. And sorry. And also PTC Mathcad's unit awareness ensures formulas are valid even when different units are used. So this is also an added advantage for them. Earlier they had difficulties, and real math notation makes it easy to understand and troubleshoot calculation. So you can see the value what they got it in the solution, as well as PTC Creo provides powerful 3D modeling capabilities. So we gave them like Creo as well as Windshield to automate the workflows on data management. So with all the solution what we gave them in order to address their initiatives and challenges what they have been facing, end of the day, what was the result they found? The result was that it was very drastic change in that. You can see that they were 90% faster. Project that took 3 weeks to they completed in just 1 day with PTC Mathcad, as well as a small team creates a standard formulas leveraged by ZF wind turbine power engines. So it's not that a larger team involved with programmings, all those things. It's a small team. They started to use the standard formulas and create that standard templates, and it's more readable equation, makes errors easier to spot and fix. So this is an added advantage. You can, if you're not using any programming language, if it's a straightforward document, any person who is new, he can go ahead and find out that what is the problem, and he can easily identify and fix that at that spot itself. And last, see that less time wasted troubleshooting for in terms of commas or brackets in Microsoft Excel or Visual Basics. So if you just miss out a simple comma there or a bracket, then the entire problem statement, you need to see where you have missed out and what is the problem. That is again a bigger error. You need to go ahead and find out and fix that. So lastly, project that took weeks now, modeled in a few hours with PTC solution. That is what our customer was able to see, that with using our right solutions, suite of solution offered to them. So with that said, this is what I wanted to walk you through with our engineering calculation solution, PTC Mathcad, which will help you to address the day-to-day challenges what you're facing, as well as fix up, right, a standardized process how you can achieve and make use and get benefited out of our solution, so that end of the day you reach market at the faster rate, as well as you provide that quality of product that has been expected by your customer, and you gain that credibility from the customer, so that you sustain in the market for a larger time. So it's a win-win situation for both of us. So that said, I'm open to questions, as well as Vinny, you wanted to take up any, you want to add some points or anything, feel free to do that. So it's over to you, Omer, or else, Vinny, you can take it forward from here.
My side don't have. So thanks for everyone joining. How about Omar?
Yeah, I think thanks. I would like to say thank you everyone for joining. I hope this was an informative session for everyone. What we can do is maybe we can try to have some engagements with each and every one of you, and see, how is it that we can bring this solution to solve the issues you may have or may foresee coming. So thank you again for everybody for sharing and coming here and letting us share this solution with you. If you guys have any questions, please do drop it in the comment section, or you can always email us and we can follow up from there. Thank you, Vinod, for your time. Thank you so much for explaining the solution to everyone here. Yeah, so we
Yep.
will just wait for a while to see if
Yep.
there's any questions. Otherwise, thank you again, everyone. Yeah, thanks, Vinod.
Yep. Thanks for
By
that,
the way,
Omer.
for this MedCat, actually BTC PTC they got provide a free 30 days free trial. So after this webinar, I will drop you guys an email for this free trial, so you guys can register from there.
Yeah, and if
Mm.
what I would like to add on top is that if anybody who would like to utilize the free trial version, if anyone is facing any technical issues in terms of installation or getting access to it, you can always let us know, and we will be more than happy to assist you there.
Yep. Uh, any questions, feel free to put that in the comment box. We'll be happier to help you to address that.
I have a question, Vinod, if that's okay. For this MathCAD, actually, what we see in the market here, and the understanding and perception of people is that it's competitive to the solution that is more commonly known as MATLAB. So, is there any significant, like notable difference that you would like to, I don't know, maybe mention?
So, it again depends upon the use case which they are working on, what the problem statement, if they are into any product development as well as engineering calculation, you can see that with the demonstration, you are not using any coding here. It's self-explanatory. That's a bigger added advantage for any user, who's working on this solution. You don't have to learn much of the programming language here to go ahead and define.
Mm-hmm.
That's an added advantage for any customer end of the day, because any engineer who is working with mathcad, he would be able to easily quicken, easily up and running within no time. So it's similar to your with your word document, like if you're prior to work with that, it's as simple as that. So that makes a huge difference there, as well as uh, there is a slight difference when you go ahead and do with Mathcad as well as MATLAB. Depends upon the problem statement, what you wanted to bring in, how you wanted to go forward and work. So if you see the user interface itself, when you compare with different MATLAB and Mathcad, the ease of use, the intuitive, it's a whiteboard, as I said during the initial discussion itself.
Yeah.
You're not being put into multiple windows. It's a straightforward single window, and
Yeah.
also documentation all makes it easier when you go ahead and define a problem. For an example, any engineer when he's doing a problem for any stress calculation might be on an Young's modulus, in a general way, he wants to represent in a notebook or a diary. If he writes down that formula, simple formula, right? So likewise, he can do it on Mathcad. It's not that you need to work on any or language or write scripting are there to understand
Yeah.
that. So that's a bigger advantage for any customers there.
Yep, agreed, 100%. I think even for the education sector, this should be more appealing rather than more rather than a more complex solution. Let's just put it like that. So yeah, so I do see this one big difference here that I think is definitely to our advantage, not to the definitely leans towards Mathcad. So let's see how we can make life easier lah. Yeah, at the end of the day
Yeah,
for everyone.
yeah.
Yeah. So anybody else, if you guys have any comments to add or maybe any questions, please do feel free to ask.
Yeah, feedbacks are also welcomed, or if you wanted to have more any of our other solutions, like you want a session on our CAD or our IoT or PLM or AR, you can also put that. We'll make note of that, and probably we can fix up another date and we can deliver a session on that also.
Yep, definitely.
I hope this session was informative, and when you walk out of the session, you add something, something new that will help you to address your current challenge. That is our whole intention, so that you'll be up and running in no time. That is what we wanted to make sure to our customer.
Yeah. I think yeah, thanks Vinod. I think we will call it an end then here,
Yeah,
since I don't see any questions. Let me just check the
Hello.
chat.
Can you share
Yeah,
this recorded video so that we can go through again? Thank you.
sure.
yeah, Daniel, we
Definitely.
can do that. Yep.
Yeah. We will have the recorded link sent over to you after this webinar, and then you can access it there, no problem. Any other requests before we call it an end from anyone else?
So in case if you are not able to view this, recording after sharing the link, feel free to revert back to us. We can send you another link if you're not, because last time one of our customer replied that they had difficulties in viewing a Microsoft recorded session. After this call, Vinny will send you a recorded link. If you're not able to view that, please revert on top of that. We'll make sure that we'll send you a new link, which will help you to view that. So I'm not sure whether it's from their end or our end with the Microsoft Teams. So that's what. Feel free to revert back on that also. So we'll share it across to you on a new link.
Okay, I think we know. Then we'll call it an end. Yeah.
Yeah.
Unless there's anything else. So again, thank you everyone for taking out the time to join us, and hopefully you guys learned a few things here, and we are happy to do it again and again, as long as you are willing to let us present intuitive solutions to you. So again, thank you so much. Thanks Vinod for your time. Yeah. Have a
Yeah.
nice day, everyone.
Thank you all. Have a great day and a weekend too. Thank you.